Diheterozygous rabbit was crossed with another diheterozygous rabbit. A rabbit breeder performed multiple crosses and collected enough data to test the prediction that the genes for fur length and fur color show independent assortment. The rabbit breeder placed the results in the table below. Carry out a chi-square test using the table and determine whether the genes show independent assortment. To carry out a chi-square test, we need to first formulate null hypothesis. All null hypotheses for such tasks will sound the same. There is no significant difference between observed and expected results. You can add a following phrase that would show relevance to this specific task. The traits are not linked and they assort independently. Next step is to calculate the chi-square value itself. You can use this table as shown on the screen. So first here in calculation the chi-square value, you need to find observed total. Sum of all the observed number for individual traits will give us observed total. Then you have to determine the expected ratio. To determine the expected ratio, you could carry out all genetic work, but you don't have to. Keep in mind, any diheterozygous crossing with another diheterozygous organism always give 9:3 to 3:1 phenotypical ratio. In order to find the expected number, we need to take the expected ratio for each trait, divide by total of expected ratio, and multiply by observed total. Fill out the next column and the last column. Don't forget to sum up all the last column results to give a final chi-square value. So here, chi-square calculated value turns out to be 1.036. Next step, we have to find the degree of freedom. Degree of freedom is found by subtracting number of traits or categories by 1. So 4 minus 1 will give 3. Then we have to find the critical value. In order to find the critical value, use the table, chi-square critical value table. It is always provided to you. We have to take into consideration in our biology class probability of 0.05. So intersection between 0.05 probability and degree of freedom of 3 will give us 7.815. On step 5, we have to compare calculated chi-square value with chi-square critical value. And it turns out to be that critical value is greater than the calculated value. So what does it tell us? Since critical value is greater than the calculated value, null hypothesis is accepted. There is no significant difference between observed and expected results. Therefore, the traits are not linked and they assort independently. Difference between observed and expected results due to chance. The traits are independent of one another.